Understanding the PCB design for half-adder multiple circuits combination involves various logic gates to create a multiplexer, encoder, de-multiplexer, and decoder. Such circuits have certain qualities, such as the circuit's output more depends on the levels which are present at the input terminal. Such a circuit lacks memory, and the previous input can't influence the current input. The combined circuits consist of inputs and outputs. A half-adder is an electronic circuit that adds two binary numbers. So, two single binary numbers act as adders in this case. It can return the carry and the output, and the representation in practice involves the XOR and logic gates. There are two inputs in a half-adder circuit, including A and B, generating the sum and carry. So, the number of outputs is also 2 in this case. Like S and C types of combinational circuits, half-adder, full-adder, encoder, subtractor, decoder, multiplexer, demultiplexer. Understanding the half-adder. Half-adder is a digital circuit in PCB that provides an addition to binary numbers. In a half-adder, a number's weight is based on the binary digit's position. The binary numbers are only from 0 to 1, of which 1 acts as the largest number and 0 as a smaller digit. The two inputs of the half-adder generate two outputs, so it is the simplest electronic circuit in the PCB. The inputs A and B are the bits where addition is required, whereas the sum and carry are the outputs abbreviated as S and C. Half-adder. Explain the half-adder circuit has two gates, including XOR and AND, and both have the same inputs. However, each gate generates the output, like XOR generates the sum and AND generates carry. Half-adder facts. According to engineers' calculations, if both A and B inputs are 0, then both outputs like S and C would be 0. However, if any of the input is 1, then the S or sum will be 1, but the C or carry will be 0. However, if both A and B inputs are 1, then the S or sum will be 0, and the C or carry will be 1. The half-adder in a PCB performs additions according to the inputs applied. 2-bit half-adder. You can have the following combinations, such as 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, 1 plus 1 equals 10. In this equation, 1 plus 1 equals 10, but it should be 2-bit output if rewritten, such as 0 plus 0 equals 0, 0, 0 plus 1 equals 0, 1, 1 plus 0 equals 0, 1, 1 plus 1 equals 10. In this case, the normal output is the sum, whereas you should consider carry as a carryout. It is easy to implement a 1-bit adder through an XOR gate. If you want to add two 8-bit, you can do it through the full adder because the half-adder is suitable for the addition of one binary digit. For two binary digits, you will have to reduce the truth table. But, for a 3-binary digit adder, the process of addition through a half-adder should be done twice. Likewise, a 4-digit adder involves another repetition of the half-adder addition. The entire process shows that it is easy to implement, but it takes lots of time. Half-adder IC. You can implement the half-adder by using the high-speed CMOS digital and logic-based printed circuit board. Understanding equation. It is easy to identify the equation of the half-adder PCBs through two concepts, such as the sum of products, SOP, and the products of sum, POS. The Boolean system of such PCBs helps find the relations between the inputs applied and the generated outputs. Designers draw the K-maps to find the equation, and the maps are based on the facts. The K-map has two equations, as it has two logic gates. The K-map for the carry brings the below facts. C equals A dot B, whereas the K-map for the sum or XOR brings S equals AB. Applications of a half-adder PCB. The basic half-adder has several applications, such, it offers additions on the binary bits, and the logic unit and arithmetic lying in the computer need a half-adder circuit. The half-adder circuits when combined can produce full-adder circuits. Such logic of half-adder circuits helps in designing calculators. So, the PCB in a calculator prefers a half-adder circuit. The half-adder circuit also helps calculate tables and addresses. Other than additions, the half-adder circuits can also handle different digital circuits applications. So, you can consider it a vital part of digital electronics. Implementing the half-adder through an NOR gate. NOR is a universal gate that helps implement a half-adder. Implementing the half adder through NAND gate. The NAND is also a universal gate that shows that you can design any type of PC board through NAND gates. In this type, the carry output is produced through one NAND gate's output being applied to the input, which is another NAND gate. The second NAND gate is AND gate generated output. The sums output equation can be produced through the output of the initial NAND, but with A and B inputs. In the end, the outputs generated by the NAND gates are again tried on the gate, producing the sums output. Hence, the standard adder in a digital PCB is easy to design through different logic gates. However, the addition of multiple bits is hard and it becomes a half adder's limitation. Understanding a full adder PCB. The full adder circuit includes three inputs, such as A, B, and C, which add three numbers for input, generating the carry and sum. Whereas the number of the outputs is 2. The main reason for half and full adders is the addition. If carry is produced through a previous addition, you can add it to another, unlike a half adder. Difference between a half and full adder. A full adder involves two AND gates, two OR, and two XOR gates. Full adder is applicable in digital processors, and additions of several bits. You have to combine two logic gates for PCB design with a half adder. But, a full adder consists of 3 gates. Half adder is required in the electronic devices to calculate additions. But, the full adder is applied to the digital processors to add a long bit. You can have a high output in full adders. Moreover, they involve a high speed and are very powerful in supplying voltage. Full adder is also suitable for GPU, or graphics processing unit. How are half adder and full adder similar? Half adder and full adder have one thing in common, and that is the addition, as both are combinational circuits and don't need a memory, like sequential circuits. FAQs. What is an adder in PCB? The digital circuits have different benefits, and if their main focus is to provide an additional, it is called adder. It has two types, including the half adder and the full adder, depending on its inputs and output. However, the output is called sum and carry. Adder is used in different kinds of processors other than just computers. They are constructed for several numerical elements, such as binary code, decimal, or XS3. Is there any limitation of a half adder? Yes, the half adder has some limitations. Like, it cannot add the carry bit produced from the previous or old bit. So, the half adders can't perform additions in the case of multiple bits. What is a full adder in PCB? A full adder includes 3 inputs, such as A, B, and C, which add 3 numbers for input, generating the carry and sum. Whereas the number of the outputs is 2. Where to use a half adder circuit? PCB with a half adder is used in calculators and digital devices. It has a simple design and you can convert it to a half subtractor. How many types of combinational circuits are there? The types of combinational circuits include the half adder, full adder, encoder, subtractor, decoder, multiplexer, and demultiplexer. What are the uses of a half adder? A half adder offers additions on the binary bits, and the logic unit and arithmetic lying in the computer need a half adder circuit. Moreover, half adder circuits when combined can produce full adder circuits. The logic in designing calculators. So, the PCB in a calculator prefers a half adder circuit. The half adder circuits can also handle different digital circuits applications. Wrap up. A half adder is an electronic circuit that adds 2 binary numbers. So, 2 single binary numbers act as adders in this case. It can return the carry and the output, and the representation in practice involves the XOR and AND logic gates. There are 2 inputs in a half adder circuit, including A and B, generating the sum and carry. So, the number of outputs is also 2 in this case, like S and C would